Okay, have you ever wondered if chemical reactions can fight back when disturbed? Now, let's study the principle that this follow. It is what? Le Chatelier principle. In this class, I'll be teaching you what is Le Chatelier's principle, how it works, factors affecting equilibrium position. First, what's Le Chatelier principle? The principle says that when a system at equilibrium is being disturbed, the system will adjust so as to oppose the disturbance and restore equilibrium. So if you have this system in equilibrium and certain factor in it are being disturbed, so what we call the system is in equilibrium is balanced. That is the character, it is balanced. Now, what you call disturbance is just simply change in conditions. And what is the response from the system? It adjusts so as to remove that change. That's all what Le Chatelier principle is saying. He said when a balanced system is being disturbed, and disturbance simply means change in the system. And what are these changing? We have concentration, we have temperature, and we have pressure. Then it will respond by what? Adjusting so as to remove any of the change that comes into the system, so as to restore itself back into a state of equilibrium. Now let's look at the effect of each of these factors affecting a state of equilibrium. One, concentration. Now, for a system in equilibrium, A plus B going to form C plus D. How will concentration affect it? Now, an increase in the concentration of A for a system in equilibrium will lead to what? It will shift the equilibrium position to what? To the right. Why? Because the additional increase of A will what? The system will try to use it up. Because if it doesn't use it, you have disturbed the system. So you have altered the system by increasing A. So the system will use A up. And how does it use A? Use it by forming what? More product. So when you increase the concentration of the reactant, you shift the equilibrium position towards the product, and more product will be formed. You understand? So increase in A, increase in concentration of reactant will shift the equilibrium to what? To the right. All right. Now another way is by what? Removing the product. Let's say D. When you remove D from the system, now you have altered the balance in the system because D has been removed from the system. What will happen? More of A and B will combine so that D can be brought back to the system and the equilibrium will be there. So when you remove D, equilibrium will still shift to the what? To the right, and more product will be formed. Please follow this carefully because they are all applied in what? Industries. All right, let's look at temperature. Temperature. How does change in temperature affect a system in equilibrium? Excuse me. Change in temperature. How does it affect a system in equilibrium? Now, we discuss temperature under two topics. Headings. Delta H, when the enthalpy is negative, and when delta H is what? Is positive. When it is negative, we say it is exothermic. When it is negative, we say endo. Exo means it gives heat to the environment. Endo means it accepts heat from the environment. So, for an exothermic reaction, an increase in temperature, if you increase temperature for an exothermic reaction, something that is already giving out heat to the environment, if you increase the temperature, it means you are countering it. Therefore, it will not favor the production of product. The equilibrium position will shift to the left when you increase the temperature of an exothermic system. That is delta H equals to negative exothermic system. The equilibrium will shift to the left. Now, for an endothermic system, if you increase the temperature, the equilibrium will shift to the right. So this is how the effect of change of temperature affects a system in equilibrium. All right, let's look at the last one, the effect of change in pressure. The effect of change in pressure. And for it to happen, it must be gaseous reactant. For example, nitrogen gas reacting with hydrogen gas to form ammonia. Now, for a system in equilibrium that are gases, an increase in temperature, an increase in pressure rather, how does pressure affect it? Increase in pressure, it will affect, an increase in pressure will shift the equilibrium towards the side with fewer gas molecules. Now, On the reactant side, there we have 1. Then here we have 3. That is 4 molecules on the reactant side. On the product side, we have 2, just 2 molecules. So when you increase pressure, it favors the side with fewer gas molecules. Why? Reasons being because when you increase the pressure now, the system is already, the pressure is increased. So it is fewer molecules will exert less pressure, therefore having a space to accept the new pressure that is coming into the system better than where more pressure will be exerted. That is why the equivalent position will shift to the side with fewer molecules. Is that okay? So that is what happens when you increase pressure in a system like this. So to recap, we discussed what Le Chatelier principle is, how it works. I would say the factors that affect Le Chatelier principle are what? Temperature, concentration, and pressure. All right. Please, if you find this interesting, give us a follow, like, share, and comment. In the next class, we'll be discussing the Haber process and the contact process, real-life application of Le Chatelier principle and chemical equilibrium. See you in the next class.